So thank you for coming out. My name is Cory Rylan. This talk is the state of web components. So quick introduction. I'm a Google developer expert for Angular and web technologies. I work at VMware as a front-end developer on the open source Clarity design system. This is a design system for VMware products that consists of UX guidelines and a suite of Angular components, and very recently, web components. So what we're going to cover today are these 5 key points. Why web components? Why would we want to use them? When should we use them? When does it even make sense to use them? We're going to do a brief intro to how they work, just so we're all on the same page. And then we're going to dig into where do they work. There's some nuances on how web components work and how they integrate into different various frameworks. And then we'll kind of review a case study of how we handled web components on the Clarity design project. And then finally, we'll do a review of the web component ecosystem and where it is today in terms of what tooling options we have available, how easy is it to get started, and how well it's growing as a community. So the primary use case we try to solve with web components is reusable user interfaces. We want a component model that is reusable and portable, and the portable part is key. We can go to any front-end framework like React and Angular, and we can create reusable components. I can create an Angular component, package it up, and share it with other Angular applications. But we want that portability to be able to share that component across different frameworks, regardless of whatever that application is using. Interesting enough, Kyle actually brought up a really good use case prior to us starting about a really good React component that solved a good use case, but the host application was Angular. So we had to jump through hoops to integrate it. And this is where web components can come into play. Also, accessibility. Accessibility on the web is pretty tricky. So having to rebuild the same thing over and over again, especially complex nuances as accessibility, it's a lot of lost dev time. So if we can find a way to encapsulate that and reuse it, that's great. And lastly, stability. We want these things to be stable. We don't want to have to recreate these components or them be susceptible to framework churn or breaking changes from a framework. And we see that in the front-end world, the kind of constant growth and change. Start out with some JavaScript, some script tags, maybe Bootstrap, Foundation, and then things grew. We realized, well, we need a bundler to manage our dependencies and bundle our code. And we're writing so much code that we need a type system. So we need to integrate TypeScript now. And then we realized, oh, we need a component model. How do we share this code? How do we reuse it? And then we get into framework level. We need testing and end-to-end testing systems, dependency injection. And we just pull in more and more things that are all susceptible to change as they're external dependencies we don't control. And it just continues to grow. And this isn't necessarily a bad thing. This is what drives the web and constantly improves things. But we don't want to keep churning on creating the same UI over and over again. And this is the particular use case that web components help solve. Web components not necessarily trying to replace a framework or a UI library, but they offer that component model in a way that is really portable. Now, web components is not necessarily a single standard. It's just a collection of different web APIs available to us. The first one is the custom elements API. Now, this is the primary API to define your own custom HTML tags. Shadow DOM and HTML templates are kind of add-ons. They give us the ability to encapsulate our CSS so we don't have global CSS kind of clobbering each other's components. And we can use modern JavaScript and CSS features for advanced theming and better performance overall. So we're going to look at a use case here. We're going to take a simple kind of alert notification component. This component is pretty basic. It has some dynamic content that shows our notification message and has one kind of interaction point. That's our close button that the user could click. Now, what would this look like as a web component? So starting out, a web component is just an HTML tag. There's one restriction. It must have a dash in the name. That's to prevent collisions with existing HTML elements. And with that tag, we can start to add our own HTML attributes to describe the state of that component. So here we have status success. It could be status danger, status warning, and it could change the component based on that attribute value. So we could change the color. Another API feature, which is part of the Shadow DOM API, is content slots. So this allows us to project content into the component. So this would be very similar to, say, ng content in Angular or children in React, and just lets you project that content in a particular area of your template. So this would be common in things like cards and modals as well. Then we can add on CSS custom properties or the newer CSS parts API. Most web components use Shadow DOM to encapsulate all the styles, which is a really great benefit. But at times, we want to be able to customize these components. We want to be able to theme them and just to change the styles. And to do that, we can use CSS custom properties or variables to be able to essentially open up an API to what is allowed to be styled on our component. And this gives us much fine-grained control over how the component looks and how it feels. This is really important for UI libraries and design systems that want a certain level of consistency. Then we have JavaScript properties. So we can pass data in via HTML attributes, but just like any other DOM element, we can query our custom element and we can start setting the properties on that DOM object reference. So here I can query the app alert and I can set a custom property I created called dismissible. And I could toggle whether or not the dismiss close button should be visible or not. And then lastly is custom events. So we pass data in via attributes and properties. We can get information back out of the component through custom events. So our components can define their own custom event, and then our host application can listen to those events. So here I have a close change event. Whenever the user clicks that close button, it'll notify us of that event, and then our host application can do whatever it needs to handle it. So real quick, we're going to just run through the code of how we would create this alert component with just vanilla JavaScript and see some of the shortcomings with the current APIs available to us in web components. So the first step is we need to create the class for our component. We extend the HTML element, and then we register that class to the custom elements API. So we do custom elements.define, give it the tag name, and then the class reference. And at this point, this is a valid custom element, but doesn't really do much. This is where we can start adding in some of those standalone features outside of the custom elements API. So here we create a shadow root, which basically allows us to turn on Shadow DOM. Tells the browser, hey, for this particular element, I want you to use this template, and I want you to have Shadow DOM turned on, so all the styles are encapsulated to just this component. Our next feature is using content slots. So this is that content projection type of feature. So whatever content the user puts in our alert, it's going to get rendered where our slot tag is placed inside of our template. So now users can dynamically pass in HTML into our component. Then we have our CSS custom properties. We can bind our own properties to the host selector, which is just the component itself, so app-alert. And then with that, they can set those properties, and those properties can be reflected into other HTML elements using just regular CSS selectors. Now, with styling web components, right now, you have to place the styles within the template using a style tag or reference it with like a link tag. Now, it's not a really great way to write CSS. You can extract this out into standalone files with Sass or Less or whatever preprocessor you want. You'll just need some kind of build step to inject those styles in at build time. We'll come back to that in a little bit. And this is where we start to see even more rough edges of kind of how low level these APIs are. So that dismissible property, to get that working, we have to write a lot of kind of imperative code to get it up and running. So we have a getter and setter for our dismissible. So whenever it's set, we can query our template for the button and then toggle whether it should be visible or not. So it's not very declarative. It's not like JSX or Angular where you can use ng-if and it binds to a property. It's very much kind of vanilla JavaScript. And then we have to remember our HTML attributes. So that dismissible sets the property, but if we want users to be able to just set attributes on the HTML in their own templates without having to get a reference to the element, we have to tell the browser explicitly which attributes it should be watching for changes. So we implement the static observed attributes, and this tells the browser, hey, whenever the status attribute on this element changes, notify me. And then we can get those notifications with a lifecycle hook attribute changed callback, and that'll give us the old value and the new value. And then lastly, we can implement our custom event for our alert. So we grab our close button reference, we add a event listener, we have click, and then whenever that fires, we can dispatch a new event. So new custom event, the event name, and then the payload for that event. And you can pass any value into that event. So it could be an object, array, number, doesn't matter, as long as it's on the detail property as the restriction. Now that code wasn't the most fun code to write. It's kind of low level, not very declarative. It works and it's very portable, but we can go one step further. And this is where the web component ecosystem has really grown over the past year or two. So the most common, probably popular tool to write web components today is lit element. A lit element is a really lightweight base class. This comes from the Polymer team at Google, and it kind of takes and abstracts some of that low-level imperative code away. So it's much easier to write. And if we look at this code, if you're coming from Angular, this is going to look pretty familiar. First here, we have the custom element decorator, and this will register our component for us. We pass it the tag name, and it does the registration automatically. On our class, instead of extending the HTML element, we extend lit element. And what this will give us is a few new lifecycle hooks and some kind of basic change detection mechanisms. So we get that more declarative style that we're used to in other libraries and frameworks. With lit element, it also provides all these TypeScript decorators. And in these decorators, we can set our properties that we want to be our public API. So we had dismissible and status. So we can use the decorator to tell lit, whenever these properties are set, I want you to re-render. So this would be closely equivalent to the input property in an Angular component. And what's nice about this is it keeps the attribute and the JavaScript property in sync. So no matter whichever one your user uses, whether they set dismissible or status in the HTML or in the JavaScript, lit will make sure that both of them are set automatically. And then we come to our render template. So we can render our templates out. We use the JavaScript template tag. And this allows us to create templates and use JavaScript expressions to conditionally change our templates. So here, based on dismissible, we can show or hide our button. And with lit element, it gives us some declarative bindings similar to Angular. So here we have @click, and then we call the method dismiss alert. This would be closely equivalent to the parentheses event binding syntax in Angular. It's just instead we use @. And this just helps clean up our code quite a bit. And lastly, our method just simply calls the native custom events API. So compared to our prior code, this cleans it up quite a bit. Now, another thing that's really nice about some of this tooling is this is a little video of this alert component. And because we're using TypeScript in the decorators, we can actually express this type information to the TypeScript language service. And using a couple different extensions for various IDEs, you can get auto-completion and hints right there in your HTML for your web components. And this is kind of a feature that a lot of libraries like React and Angular have had for a long time, but now we can get that natively with the web. Now, there's an argument against, well, web components are supposed to be native, and if you're using lit element, then why don't you just use a framework or an existing library? The whole point is to not have dependencies. And I think that's a fairly valid criticism. However, the difference is these web component tools are extremely lightweight. They rely on the native web component APIs and just provide a little bit of sugar on top to make it easier to use. So this screenshot is a demo application using the Clarity design web components. So this is what I work on as my day-to-day job. And we develop a suite of web components for the Clarity design system. And this is kind of our Hello World app. And on this Hello World app, we have two of our components. We have the badge component, so kind of like a little notification style component. And then we have our icon component. And our icons component provides, I think, just shy of 500 different SVG icons, so quite a few. So we have two components on this page, and this particular demo uses rollup.js. And our final build output is really small. We have a little bit of global CSS for some of the typography, but the JavaScript bundle is very tiny. We come in at just over 15 kilobytes compressed. And that includes our two components, the icon and badge, as well as importing two of our icons, the little search icon and edit icon over here. If we drop the icon component and just import the badge, which is, I believe, our smallest component we've built, that puts us about 10 kilobytes. So we can get a Hello World web component using something like a lit element within about 10 kilobytes, which is just extremely small, lightweight performance. So as users of our design system, this is really important because this means as they use more and more of our components, they're paying a very small price in terms of performance to be able to use that component. We've already loaded all of our dependencies. We've loaded lit element, and we actually have a few more internal dependencies that have already been loaded as well. So every component they add only adds a couple of kilobytes at most. So we get really good performance. And this allows us to be able to render extremely fast. So that demo there, we get a first kind of paint to view in about 1 second on mobile. I think this is the mobile 3G view. This particular demo you can find at this live URL, and then the link for the repo example is here as well. I'll share these slides out after the presentation. So we can author using some new tooling for web components, but where do they work? For the most part, they work everywhere. This is from customelementseverywhere.com, and it runs a series of end-to-end tests against the web components and different various frameworks to see how well they integrate. And they all pretty much work without issue, with the exception of React. And we'll see that and why in just a second. So our alert component pretty much works the same across all the different frameworks. It comes down to just syntax differences between the frameworks. Most frameworks treat custom elements just like any other HTML element, because that's what they are. You can set attributes and properties, you can listen to custom events, and you can pass content in through the slots API. So to the framework, it's just another HTML element. There's nothing special about it. So in Angular, you would treat it just like any other HTML element. You can just set the attribute, you can set the property with the square brace syntax, or you can listen to the events with the parentheses. They even work as far back as AngularJS, I believe 1.7.3, they added the ngprop and ngOn directives. And this allows you to generically set properties and listen to events on the custom element in AngularJS. This is really important because this means you could possibly use web components as a migration step. If you have a large AngularJS code base and a large Angular code base, you could extract any common reusable components or views from your Angular code base as custom elements, and then drop those right into your AngularJS application and start deleting some of that AngularJS code. And you could do that really with any framework. So that's something to keep in mind, is custom elements can kind of be this bridge between framework migrations. Vue.js, very similar to Angular, just slightly different syntax, shorthand bindings. Preact works the same way, but slightly different. For Preact, it will bind to attributes and properties. However, it doesn't have a way to express the difference between attributes and properties the same way Vue or Angular does. So what Preact will do is it does a runtime check, and it will check, is there a property available that I can set? And if not, fall back to the attribute. So it still supports both. It just doesn't have that explicit declaration. And you can bind to events the same way. You just prefix on for whatever event you're hooking into. Lastly, that leaves us with React. So React has two primary issues that prevents it from working well with custom elements. The first issue is how it binds to properties. React does not treat JavaScript properties on a native DOM element the same way as most other frameworks. When you set a value on a custom element, it always treats it as a HTML attribute. And that can work some of the times, but when you start to get into use cases where you want to pass in complex objects like a JavaScript object or an array or type number, this is where it falls over because attributes are always strings. The second issue is React events don't work with custom events. It uses its own kind of synthetic event system, so it doesn't understand how to listen to those native DOM events. So because of this, it's really hard to get data into the custom element, and it's hard to listen to that. You could use refs to grab a reference to the DOM element in React and just kind of imperatively set it like we saw in the vanilla JS example, but that's still really clunky. Luckily, however, those two incompatibilities are pretty easy to work around. For clarity, we built a really small, lightweight React wrapper component. And this component, you give it the custom element tag name and the reference to the class, and it will give you back a React component that wraps that custom element, and it kind of bridges the gap between React and the custom element. So for clarity, all of our React teams can still use our custom elements. It would just look like this. To them, as a public API user, it's just another React component. But under the hood, there's a base class that's kind of doing this mapping for us. And it's pretty small. It's, I think, maybe 70, 75 lines of code. So it's pretty lightweight. Browser support is really good. Works across all the major browsers without issue. Of course, it doesn't work like everything else. It doesn't work in IE 11. You can use polyfills to get around this. The performance is decent compared to other frameworks running in IE. It's pretty decent. However, something to keep in mind, mainstream Windows 10 support for IE is ending really, really soon. So something to keep in mind with your browser support matrix. So real quick, I'm going to kind of just show a quick demo of the Clarity web components and kind of what I do day to day and some of the things we've learned from web components. So this is our main website, Clarity Design System, and it's all open source on GitHub. And we started out as a suite of Angular components. And this worked pretty well for VMware. There's a lot of big enterprise type applications, hundreds of developers, and it gave a lot of structure for those applications. But as VMware has grown, there's acquisitions, there's new teams, new products, and believe it or not, they didn't all pick Angular. So some of these teams coming in have huge React code bases or Vue.js or legacy code. They have massive AngularJS code that they're trying to migrate away from. And when they come to the design system, this is where we fell short. How do we help them? Well, we can't really give them Angular components. That's not going to be any help for them. We can give them some CSS that the Angular components use, but that still leaves a lot of work on their end to wire things up, and it makes things brittle. And this is where we moved to web components and custom elements. So we're still working on this. This is an in-progress development, but you can find all of our web components at clarity.design storybook/core. And this is a list of all of our current custom elements. So if you want to see examples of different types of web components, how we built them, definitely check this out. I think it's a pretty valuable resource. We have a lot of different forms APIs with custom elements. I think this part is really good to dig into if you're interested in building your own web components for your teams. It's very interesting to develop things like this because we can target all these various frameworks. So our forms, for example, we've found out that if we take our inputs, the native inputs, and keep them as content that's projected in, this allows our custom elements to work with every single framework because the custom element is exposed to the host application. So that means our web components work with Angular forms. They work with libraries like Formly. Pretty much any form library just works. There's no issue with it. All of our custom element does is wraps it and kind of applies our custom styles and design for our design system. Now, our code, the repository is a monorepo. We have our Angular package. We have core, which is our web components. We also have a package for React. Now, remember that incompatibility issue we have to work around. We have the wrapper in the code base, and it's pretty small. We haven't abstracted it as a standalone library. There are a few out there that work pretty much the same way, but this is all the code to get our web components working in React. Looks like I need to install my node modules. So yeah, comes in 74 lines of code. And basically all it does is we give it an element name and it spits back out a React component. And inside there, we hook into the React lifecycle. And whenever a property is set, we can map the React property to the custom element property. And then same with events. If a prop is set for an event, then we can map that to the custom event and create the listener for them. So to the user of React, it's just a React component. But internally, this component is doing kind of this shim mapping layer between the incompatibilities. So it was a little bit of extra work on our end for maintainability, but it works really well because we can develop those components one time. And from here on out, if we want to support React, all we really need to do is, let's see, something kind of like this. So we have the badge component we saw earlier with the little green version number. For React support, we just use our React kind of shim, give it the tag name, the class reference, and now that they can consume our component as a React component. And this is all TypeScript. So we've been able to use generic types to translate the web components type, since we're using TypeScript for the custom elements, and translate that all the way through React. So when they're using like TSX, they get the IntelliSense and typing of the custom element, but on top of the React component. So from the consumer standpoint, it looks just like a React component that was written in TypeScript, which is pretty cool. So Where does this leave us with the ecosystem? Web components have grown a lot over the past year or two. I gave a similar talk a couple of years ago at Angular Lunch, and there was a couple options. There was Stencil and Lit Element. Both of those were real new. But since then, it's kind of exploded in popularity and options. I would say Lit Element is still one of the most popular lightweight options out there. If you are interested in a hooks style API, so like React hooks or Preact, look at Haunted. Haunted uses Lit Elements templating language, Lit HTML, but provides a hook style library on top of it. So you can write stateless functional components that look just like kind of like React hooks, but they output a custom element. So if you want that style, but still the portability of the custom element, it's a really good option. Stencil is a little bit more heavyweight. It's more of a compiler. So it gives you a lot of tooling up front to build and ship your components. It looks a lot like Angular. It uses TypeScript, decorators, it has a full-on kind of build step, and this project is maintained by Ionic, the mobile app development team. So you can use this and kind of get up and running really fast. So it's a really good option when you're first starting out. There's also a lot of interest and popularity growing in how to take current UI frameworks and either wrap them or have them output custom elements. So Preact being so lightweight, there's a small lightweight project that allows you to write custom elements using Preact. So when you render your template, you can just use Preact for that rendering step. And your custom element is still just a custom element. To the consumer, they just use it like any other component. But internally, it's using Preact, and it works really well. Svelte has a option with their compiler that allows you to output custom elements. It takes a little bit of extra work to kind of configure things, but it's another fairly lightweight option. And very recently, there's been a new project called Fast Design. And that's a project from Microsoft. And it's a pretty interesting project. It's kind of like a base framework for developing component libraries and design systems. It looks similar to Lit Element, gives you a base class to work with and some utilities, build steps. Also helps with things like design tokens for theming if you're a design system. It's very interesting. It kind of helps you bootstrap your own design system in a way. I think this is going to be more relevant for enterprise teams that have a large variety of products. So example, Microsoft has Xbox and Azure. Their UIs look nothing alike, but there's a lot of duplication in efforts possibly. So Fast Design can kind of help provide some underpinning for those basic needs to develop those UIs, but allow two independent design systems to work on top of it. Another option, which I highly recommend for anyone starting out with web components, is Open Web Component Project. This is an open source project that kind of gathers several different learning resources and tools for a really good out-of-the-box developer experience with web components. They do have a handful of different packages that help with things like unit testing, dev server, so you can have like live reload with custom elements, and just overall best practices. So that's a really good option. Storybook recently also added custom element support as of its latest version 6.0. And Storybook is for developing UI libraries. It's really nice for documenting your components so you can see what's available. That's what we were using in Clarity Core. Because Storybook had an original focus on React, the web component support is actually really good because the web component model mirrors very similar to React. We have properties in, events out. So the tooling around Storybook is actually really easy and has really nice integration. So if you want to document your own components, definitely look at Storybook. And then lastly, we have Vue Custom Element and Angular Elements. These are kind of on the more heavyweight solutions end of the spectrum, and they have different trade-offs. These tools you would use in enterprise environments where you have existing components or workflows and applications that you need to share across other applications. And you don't want to have to rewrite the whole thing into a web component. These tools let you wrap the component, the Angular component or Vue component, up as a web component, so it can get dropped into a different framework or a different application. The trade-off is it can be a little bit easier to drop that code in. However, you pay a performance penalty because you are wrapping parts of Angular and the whole framework up in that custom element. And if you have multiple custom elements, then you have duplication of the Angular framework across components. So there's some trade-offs in terms of flexibility, how quickly you can develop, but also the payload size you pay for with that flexibility. Lastly, check out webcomponents.dev. This is an online IDE similar to StackBlitz, but solely focused on web components. And last time I checked, they had 34 different starter kits, demos, on how you could write a web component. 34 different libraries, options available. It's really neat. You can actually write a component in the browser. And I believe if you can sign in with like your GitHub or NPM credentials and publish from the browser your component, publish it immediately as a package and start using it in your applications, which was pretty neat. So if you want to just try out the different various flavors of how to write custom elements, definitely try this out. The important thing is, even though there's so many options and it's only growing, is no matter what option you choose, in the end, whoever's using your component, it's just a web component to them. All these different tools is just an implementation detail of your component. It's all internal. So if you try one out and you don't like it, you can change it to a different tool. If you want to change it to lit element or haunted, to the user of your component, it shouldn't matter. It's just a custom element in the end. And that's it. So the demos for the alert, I have 2 of them on StackBlitz. I'll share out these slides as well. There's the vanilla version, just plain JavaScript, and then there's the lit element. So those will both be available. I've got the link to the Clarity components. So if you want to see just at scale lit element being used, definitely check that out. And you can find more content about web components and education resources on my blog and webcomponent.dev. So thank you for attending. Hopefully everyone learned something. I will leave it open for some questions. I think we have about 15, 20 minutes.
I'll go first with the question. So Cory, my question is, so you showed us some lit element code, and I think you said that that's like the main thing that you're using to build Clarity, if I understood right.
Yeah.
So like on a daily basis, like are you more of a web component developer or more of like a lit element developer? Like which one, like which layer defines the words you use in your program and like the semantics you think about and so on?
Yeah. I would say if someone asked me, I would say web component developer. Especially using lit element, it's such a thin layer that you have to know the web components API to use it. You still use the web component lifecycle hooks. It just gives you a little bit of sugar for your templates on top. So yeah, I would say I'm a web component developer, not really defined by the tools.
This is Mark. I have a question about the shadow DOM and what that does to your use of CSS. You talked earlier about how you try to anticipate when you write a component what ways you'll want to override the styling, and then you expose CSS variables to allow that. Quite a while ago, when I was doing some things with Polymer and web components, it seemed that we were constantly running into cases where we just didn't anticipate something like that. And we were constantly going back in and modifying our components, add another variable, add another variable. I wonder if that's your experience and whether that becomes kind of tedious. And do you wish that it wasn't so locked down like that, so that from the outside of a component, you really could style anything if you really needed to?
Yeah, that's a really good point. So I think it depends on your use case. For Clarity being a design system for VMware products, we kind of want things a little bit more locked down. So when we ship a component, we kind of do the absolute minimum of exposing what's available for customization. And then as use cases come up, then we start to expose things as we go along. However, like you said, it can get really verbose. The API that would help with that would be the CSS parts API. I didn't have a demo of that particular API, but this works really well. What this allows you to do is inside your web component, you can expose a particular DOM node to be completely public and styled. So for our alert component, I could define a bunch of CSS custom properties, how to style that particular close button. But there could be like 50 different properties. I don't want to define all those. With CSS parts, in my template, let's see, where's their example? You add an attribute part and then the name, and now that exposes it publicly. So the user of your component can write a selector like this, and they have access to that particular element. So they can add any CSS that they want, and you don't have to write 50 different custom properties. And what's nice about this is you can hide the internal DOM structure of your component, but still give them like hooks to style into. So I think this is kind of like the happy medium to find with web components.
Nice, thanks.
I'll ask another one if nobody has one ready yet. So Cory, it seems like there's like a new flock of tools built on top of the Web Components API to make it increasingly convenient and abstract and more developer efficient and so on.
Mm-hmm.
Are some of those tools getting to the point where you might consider using those like as your as the way you develop your application? Like are some of those growing to the point that they're like competing with React and Angular and Vue and so on? Or are those still imagined as being only for like building your low-level reusable graphical components and not not suitable to build an application with? Like how many different frameworks do I have to use, I guess, is another way of asking that.
Yeah, I've wondered this a lot over the past, even just the past 6 months. There's been a lot of updates and changes. I would say first and foremost, the best use case is stateless reusable UIs. Your UI components, design systems, it makes a lot of sense to use custom elements. At an application level, I'd say currently in the ecosystem, it's possible, but I don't know if I would personally recommend it or do it. If I had a large enterprise application, I would probably still reach for something like Angular. Like if I have a team of 50 developers, cobbling together a custom elements and then like how do I handle routing? How do I handle dependencies and dependency injection if I need it? How do I handle testing? There's a lot of open questions. And if you have a large team, that's a lot to figure out in a very short amount of time to ramp up. So something like Angular is probably what you're going to want to reach. But that doesn't mean you can't use custom elements with it as well. I think eventually we'll see in the web component ecosystem more and more people building stuff tailored to web components. Like there's probably 4 or 5 routers that are for web components out there. There's like the I think it's like the Vaadin component library has a router. There's a handful of them, and they're kind of like an Angular router, but for web components. So I think it will slowly grow and expand into those areas. So I think that will be an interesting space to watch.
Well, I'll ask another one if nobody else has them. I'm trying to let everybody else go first. So I think you had pointed out that you have those React components in Clarity that like carry the types through. And I think the Angular components do the same thing, if I remember right. And then I saw you mention, or you had up on the screen a little while ago, like, oh, well, Clarity is shipping these web components, Clarity Core web components. Like, sort of what are the obstacles? What are we waiting for before Clarity would just be the web components and they would like, just work in a natural way with kind of all the popular frameworks? I mean, I know React has like a little feature thing they need to get in there, but like at some point, would I expect that I wouldn't go grab like the Clarity Angular thing, that I would just directly use it? Like it wouldn't have web components, it would just be the web components?
Mhm. Yeah, that's a discussion we're currently having. Um, the web components themselves work just fine in Angular without any issue. So we already have teams that use both. They use Clarity Angular and our web components. And they make some, using both gives them a lot of value. Example, our icons are much more performant as web components. Um, so they can get some really nice performance improvements. But they also use some of our Angular components like our data grid, which is extremely large, complex, stateful component. Now, eventually we'll have the equivalent as a web component, but our main goal is that these web components are stateless. We want them to solely be for rendering consistent experiences. Whereas the Angular components kind of have more deep integration into the framework, integration to Angular forms and some of its change detection optimizations for like the data grid. Those things are probably going to stay around for a while because they offer a lot of value at the framework level. And we've seen this in other teams where they actually use our web components and then they build their own components around them. So if they have like an opinionated pattern or abstraction for their particular product, the web components give them a good solid foundation, and then they can encode that pattern with kind of like higher level components for their particular use cases. So I'm hoping to see that more is they find the patterns that work best for them, and we're the foundation that underpins it. So I think we'll see more and more variations of a web component library, and then you'll see like kind of this plugin architecture ecosystem around it. There'll be like an Angular add-on or Vue add-on that gives you a little bit more integration with that framework. Doesn't mean it doesn't work, it just means you get a little bit more niceties and a little bit more syntax sugar possibly. So I think that will increase quite a bit.
Try to solicit another question from the rest of the crowd before I ask another one. We don't have a talkative crew today, so I've got another one. So one of the things that I notice with Angular, I notice it more with Angular than with some of these others, is that I sort of end up with an extra layer of DOM for each component. And that sometimes becomes an irritating ongoing obstacle to styling and reuse. Whereas something like, like with React, there's now a way to directly include a set of elements where the component goes. I think Svelte can do something similar, not avoid generating extra layers if you don't want it to. Is there a way with, are web components kind of stuck with that same thing where there's always going to be the layer of DOM representing it, or is there some way around that with web components?
Yeah, so for web components, I think it'll have a similar problem. There'll always be the host element tag. So like our example is app-alert. That will always have to exist in the DOM. There sort of are workarounds with tools like Haunted. So Haunted builds on top of the element, but provides like a hooks API, like React hooks. And with their API, they provide, I think, what they call virtual elements, which lets you write a hook component, but virtually. So it actually doesn't inject a DOM node to represent it. It kind of like composes it together at runtime. I think similar to kind of React, how that works. So that might be something to look into because it helps eliminate some of that extra DOM. But in the end, at some point, there has to be like an entry point DOM node for the browser to instantiate that component. But Haunted kind of helps you get rid of some of those. So if you want to abstract stuff out of your component, and not have to create a bunch of new DOM nodes to represent each abstraction, that virtual component idea that Haunted provides would get you partially there or mostly there.
We have fewer questioners than usual this week. I'll give you one more, then we should wrap up to the end of our allotted hour, and that is like in terms of how big and complex components should be. Like, what's the trade-off between like a whole feature that something big enough I should be building it in my application framework versus like, yeah, just like a single like notification panel that has one click on it. Yeah, that's great to build as like a standalone lightweight web component. And you mentioned that in the Clarity you work on, there's a couple of like large components, but those are written as Angular components. Like, is there any technical obstacle or just like waiting for the work to get done to start building some of the larger, richer components that are out there as web components? Like if I was starting today, could I build like a megabyte of JavaScript infinitely featured data grid as a web component? Or are we still waiting some technologies to be able to do that?
I would say you could do it today. You could write a full featured data grid, megabyte of JavaScript wrap in a custom element. That would totally work. The things you have to be careful about is state management with that component. This is kind of the case with all framework level components. If that data grid has a bunch of state it's managing on what should be visible, what shouldn't be visible, what data is it processing or filtering or sorting, you have to make sure that whatever state's being represented in that custom element is accessible from the outside as a user to be able to hook into, whether like through custom events, to be able to reflect that state back up. And it's important because your component is outside any possible change detection system of your framework. You can't guarantee that. So if you change that state, you want to make sure that you can notify the host application so they can keep that in sync. So if you used Redux or NGRX, you can keep that all in sync together. I think there's two use cases with custom elements that you'll see most common is the use case of like what we do with Clarity, reusable stateless components. That's the primary use case. That's the easier one. And then micro front ends. That's the other big use case. And that's the hard one. And that's where I want to take a chunk of this application and put it inside this other application. And you can do that with custom elements. You can wrap it up as a custom element and expose your data through properties and events. So you can pass data into it and get information back out. It's just, you have to be kind of careful and conscious of what data you take in and what data you pass back out. So everything kind of works together seamlessly. That's a bit more tricky, but I expect to see that to grow more and more. I saw on Twitter, I think someone kind of explained it as using iframes in the same page. That's kind of how we hobbled together different UIs and different frameworks. We embed iframes. They describe web components as like spicy iframes. So it is similar concepts. You can embed them. It's just a little tricky.